Unit number 2, operation amplifier applications. Okay, so in this chapter we are going to discuss about the different application of operation amplifier. So that is operation amplifier comparator. So we already discussed with the open loop and the closed loop concept. So comparator used in the open loop model. That is, comparator finds it's important in circuit where two voltage signals are to be compared and to be distinguished in which is stronger. That is, it is going to compare to signal. That is, we in comparator we have three terminal, two input terminal and one output terminal. If V1 greater than V2, output will be 1. If V1 less than V2 means output will be 0. So this is the simple concept. So if you are giving input as a sine wave, it is comparing the input and it will give the square wave output only. That is, comparator of output always it should be 0 or 1. So this is the basic model. This is the maximum used in the analog to digital converter circuits and digital to analog converter. They are using a different comparator model. Okay, that is a concept. That is, V in greater than the V reference means output will be V plus V plus VCC. If V in less than V reference means V out is equal to minus VCC. So the principle used in the comparator circuit is two inputs and one output. So non-inverting comparator having two types. One is a non-inverting comparator and one is inverting comparator. So inverting comparator means if I are giving, if the input is high, that is V1 high means output will be 0. If V1 low means output will be 1. That is reverse operation. Non-inverting means as well as same as concept. That is V1 greater than means output 1. V1 less than means output will be 0. Okay, let's see the diagram. So that is non-inverting input, inverting input V plus and V minus. So in this circuit, the value up to 0 to V reference, the value will be 0. So after V reference, okay, so value will be 1. So after this value, so value will be 0. So it will be like this. Okay, same concept will be defined in the output. That means we are going to take the signal, any one of the signal, and we are going to set the reference. Okay, so like that we can define the different output signals. So a comparator maximum used in the Windows models. Okay, window comparator. So window comparator means it is compare 3 levels. Okay, here we are in the previous model we are comparing the only 2 signals, but in the comparator model we are going to take the 2 reference voltages. That is a low threshold voltage, high threshold voltage. The difference between these two will be get the output. So this is the circuit for non-inverting comparator. So generally it is connect the protection diodes. So because it is an open loop model, so the power supply will affect the input. So we are using the diodes, protection diodes. So if you are giving input to that is a V in value given to the positive terminal, that is non-inverting terminal means it is a non-inverting comparator. Okay, so that means பார்த்தீங்கன்னா நமக்கு தெரியும் 0 to V reference நமக்கு வந்து 0, V reference to up to this value it will be 1. So remaining value will be 0. Like that it will be defined. Okay. So in the inverting comparator, in inverting comparator circuit, so the value inverting comparator circuit that we are giving input V input to the inverting terminal, we are giving reference voltage to the positive terminal. Okay, so this is the circuit, that is inverting model. That means 0 to V reference means here V value will be 1. So for this value will be 0. That is the reverse operation of the non-inverting comparator. So these are the characteristics to define to design different comparators. That is operational speed, accuracy, high voltage gain, high common mode rejection ratio, very small input offset current and input offset voltage have to be uh, defined for the comparator characteristics. So these are the applications of comparator, that is zero crossing detector, window detector, time marker generator, and phase meter. So zero crossing detector, so it will define where it is transferred zero. So that will be value to be zero means the output will be one. So that is called a zero crossing detector. Window detector, which is defined the three variations. Okay, here they have an example less than 3 volt, between the 3 to 5, and greater than 5. Okay, like that we have. So that is on and off conditions. If values are varying, changing means the color of the LED will be glow according to that the condition. That is, if we are giving input 4 means that is 3 to 6 condition will be enabled. So output will be the green light or yellow light. Okay. Next, time marker generator. So it will take, so where, so that means simple concept. So that means we are getting the sine wave from sine wave. We are received sine wave from the, sorry, we are received square wave from this sine wave in the comparator circuit. So if you are giving that square wave signal to the differentiate circuit means output will be a pulse. Okay. Phase meter. The phase angle between two voltages can also be measured using previous diagram. The both voltages are converted into spikes and the time interval between the pulse spike of one input and the other is measured. The time travel is proportional to the phase difference. So sorry, time interval. So one can measure phase angles from 0 to 360 with such a circuit. The symmetric trigger circuit is also called a regenerative comparator. So this is another model of comparator circuit. But here what is special? So here we are taking a positive feedback to the circuit. The circuit is designed with the positive feedback and hence will have a regenerative action. Here also it is used to regenerative is to remove the difficulties in zero crossing detector due to low frequency signals and input noise voltage. So in this trigger circuit, so they have low threshold voltage and high threshold voltage. Okay, by these two voltage, so that is VLT and VHT. So these two will be compared and we will get the output from the schematic trigger. That is schematic trigger. Main application of the schematic trigger will be a perfect students. Okay. So this is the upper threshold voltage and the lower threshold voltage formula. So lower threshold voltage formula will be V reference R1 divided by R1 plus R2 minus R2 into V set divided by R1 plus R2. Then VUT is equal to V reference R1 divided by R1 plus R2 plus R2 into V set divided by R1 plus R2. So this is the inverting schematic trigger models. So comparison of schematic trigger and comparator. So both in schematic trigger they are using the feedback. In comparators it is not used any feedback. So op-amp is used in the closed loop mode. Here open loop mode. No false triggering. Here false triggering. So two different threshold voltage exist. That is VLT and VUT. Here V reference and V minus reference, and hysteresis exists, no hysteresis. Okay, so these are the applications and concept of the comparator and the schema trigger. Thank you.